Today's lesson involves logarithms. Now, you may be a little concerned about that because logs weren't something that you were particularly fond of, but have no fear, you'll do great in here. First, a quick review. A logarithm, for example, log base 2 of 8 equals 3, and the reason that it equals 3 is because 2 to the third is 8. Or another example, log base 5 of 625 is 4, and that's because 5 to the fourth is 625. So that's basically what a log is doing. But even without doing that magic right there, we can learn just a couple of rules of logs and apply them to what we're going to do in statistics. So the first rule that we have is that the log of A times B is the log of A plus the log of B. The second rule is that the log of A over B is the log of A minus the log of B. So you don't want to get tripped up with those operations right there. And finally, the third rule says if I have the log of, say, x to the b power, whatever b is, some constant, I can just bring that b down in the front and make it b times the log of x. And that'll become a very useful rule with what we're going to do today. One final word on logs. If there's no base, if I just write the log of x, that's understood to be the log base 10 of x. Sometimes we put different bases down there for a variety of reasons, and somewhere along the way, somebody discovered that we could put an e down there and talk about the log base e of x. And as it turned out, this became a pretty useful thing in a lot of applications, and so they gave that whole part a name, and instead of writing log base e, they wrote ln, the natural log of x. So whenever you see ln, that just means the log base e. What I'm going to usually use is the log base 10, but if you prefer the natural log, you can write ln, and it works exactly the same way with the things we're going to do.